Well, hello and welcome to another DevNation Tech Talk. We have an exciting topic for you guys today. We're going to be talking to Matthias. Matthias is coming from Germany, and he's going to give us this really awesome introduction to what you can do at Knative, Kubernetes based on OpenShift, and this technology called Kafka, right? So you're going to be seeing Knative, Kafka, and Kubernetes all woven into the same story. I'm actually very excited about it. This is a demonstration I really love doing as for myself. So we're going to see it directly from the source today, and that is with Matthias. So let's turn it over to Matthias and get started.
Hello, guys. Thank you for having me, Burr, here. Let's get started. All right. So as Burr was saying, today we have a quick session about serverless Kafka on Kubernetes. And that really means we run Apache Kafka in combination with the Knative project. A few words on me. My name is Matthias. I work as a principal software engineer at Red Hat. My responsibilities there are I'm a Knative, working on Knative. I'm a prover there on the upstream project, so specifically on the eventing parts. And inside of the OpenShift Knative team, I'm leading up our internal Knative eventing team. So nowadays, a lot of people really have interest in Apache Kafka, and they love it, and they all want to run it on Kubernetes. So the best answer to that on the market right now is our upstream Strimsy project. Strimsy project basically gives you an operator which allows you a Kubernetes straightforward way of managing and installing your cluster, your Apache Kafka cluster with the zookeeper responsibilities. What this looks like is what you could see here. The operator, once it is installed, is watching for a specific Kafka custom resource file where you then declare how many nodes of your Apache Kafka you need, how many nodes of your Apache zookeeper cluster you need. And besides the cluster operator, it has another operator which gives you a declarative way to actually create users that are allowed to access the Apache Kafka cluster. And it has a feature that you can declare your topic. So in a YAML file, you specify your Apache Kafka topic, give it a name, you give it a partition and replication and what have you. So that is the introduction part for Kafka operator. Today, the Apache Kafka will be used behind the scenes of our serverless offering, and for that we use Knative. Let's do a quick recap what does serverless really mean. So what we see here is a definition from the Cloud Native Computing Foundation. And the Cloud Native Computing Foundation has its own serverless working group. Inside of that one, they have a definition or specified what the terminology really means. So I was slightly modifying this sentence with the Knative mindset kind of applying to it. So what does it mean? Serverless computing refers to the concept of running applications that do not really require server management. Serverless describes a deployment model where applications are uploaded to a specific platform and then executed, scaled, and built in response to the exact demand that you need at the moment. So Knative is really a serverless platform based on top of Kubernetes. So what's the good news here is that you can bundle your applications inside of a container and you upload it to the platform. So you don't really have the programming model here from a fastest perspective. So the serverless is really more a deployment model. You can just bundle your containerized applications, and I show you in a few minutes how that really looks like. The nice part about some of the Knative components is that based on the actual workload, we really see your container is scaled up as needed or even scaled down to zero, and therefore built with the exact amount of compute resources that you need at the right moment when your service is being executed by your customers. So that's a little introduction of the serverless program here. So let's enter now Knative. Knative consists of two key projects or two key components here. We do have Knative Serving. Knative Serving is, as you can see here, a request-driven model that serves a container with your application and can scale it to zero. So in Knative serving, you basically declare your application as a K service. That means you give it some YAML-based configuration and you're referencing a Linux container there. And then you upload it or you apply it basically, and then Knative takes care of the scaling. So if your application is requested very often and has a lot of load coming in, then the autoscale mechanism from Knative sees that and notice that there is a lot of incoming HTTP traffic here. What it really does for you is an automate based on traffic scaling. So you will see a lot of pods out of your container are coming up. It also realizes when the traffic is relaxing, and then it can scale down to the pods. And if, for instance, there is, for whatever reason, no traffic on your machine, what you then really have a nice benefit here, it can scale to 0. So that means that there is no actual running pod. And that means you're not burning money, you're not wasting compute resources with a program that would be sitting there and doing nothing. So that is one key part of the Knative project. Today, we are going to focus on a few parts of the Knative eventing project. Knative eventing, you can say it is providing you a common infrastructure for the consumption and producing events, so that will basically stimulate your application. Knative eventing can be really seen as kind of an event mesh that you can have connectors. They're called sources that can then basically access a third-party system, for instance, like Apache Kafka. They read the payload out of Apache Kafka, and they then send it along the wire to a Knative serving service that at the end of the day is your application. So it provides you really a plumbing infrastructure that you can interweave with a lot of events here. You can build event-driven applications that are based on the scaling module, can even scale to 0. So this is a very nice feature of Knative. Eventing. Knative eventing can be really seen as a universal subscription delivery and also the management of events. So it is all you need when you work with particular event-driven features and when you want to build a fully fledged application that is doing event processing with you. Knative has a few different modules here. On the right-hand side, I list the extensibility feature. So Knative on its own has a lot of eventing sources that you can basically use to access existing third-party systems. For instance, we have one upstream that is GitHub. So you can basically combine GitHub events like pull request related events with your serverless application. And based on traffic with your GitHub project, for instance, a pull request has been merged, it will trigger an event, and then Knative is the eventing part is then receiving this event and it is forwarding to your application. We also have sources that allow you to actually integrate the Camel integrations with the Camel K project. So that means all of your knowledge, integration knowledge that you have and that is applicable for Apache Camel can be also used there. Behind the scenes, the events are routed on some internal transport mechanism that is called a channel. And there is various channels available. There is the in-memory channel. That's the default thing that you get all the time and installed. And there is an Apache Kafka channel. So all the messages that are then being used internally as a transport over this channel, in our case, Apache Kafka, they are actually persisted in an Apache Kafka topic. So the benefit here is that you have all of the features that you have from Apache Kafka, like you can replay events and you can even access the events from the particular topic with your vanilla Apache Kafka tools. And there's another channel implementation for GC PubSub. So one of the big benefits here really is the aspect of the event orchestration. Being a Kubernetes-based platform, Knative has declarative API to distribute events. As I was already mentioning, it allows you to actually scale from just a few events to a fully fledged live data streaming pipeline. And we will see that later by a demo. Whereas to notice that the cloud event specification, which recently went 1.0, is first-class citizens here. So all of the Knative eventing sources, when they read data from the third-party system, they are reading the payload and they're transforming it into cloud event and is routing forward the cloud event object to your application. So the first demo that we're going to see is basically one of the very simple use cases that you can build. You can use a source that is directly connected to a service. In this case, I'm using a Kafka source, and I'm connecting it straight to a service using the sync API of the Kafka source. So this is basically the simplest way that you can imagine to get a cloud event from a Knative source to a particular Knative serving service. However, saying this is a very simple use case, there's a few drawbacks. Right now, there is no queuing support. Like when the service is unavailable, it's a one-by-one relationship, so only one service can consume it at a time. And since it's a straightforward, simple, direct connection, there's also no back pressure support. Also, there's no specific filtering. All events that are produced by the source are being received by that particular one service. So you have a one-by-one connection from the particular Kafka source to a Knative service. All right, let's take a look at some code now. Before we do that, I would like you to show the OpenShift console. I'm using OpenShift 4.2 platform here with the serverless product that we have here. The serverless operator is giving you a Knative serving project. So I was using our operators here that are integrated in OpenShift 4.2 operator hub. So you can basically do a click and install all of the features that you need to run the Knative serving parts of the demo. In combination with that, we have community operators that we wrote, which basically gives you Knative eventing. So this installs all of the Knative eventing, the feature to run different sources, the in-memory channel. And at Red Hat, we did also create another operator which bundles all of the Knative components for Apache Kafka. In our case, we are going to use the Apache Kafka source, and we are also going to use the Apache Kafka channel. So you will get that by using these operators. Now let me go to my terminal console here. All right. I have the window split it up. Here in the top of the window, I'm in a watch loop that is basically getting all of the pods that are deployed in my OpenShift's default namespace. And let me go into my first demo here. Let's see. Okay. So I was installing two different YAML files here. Let's first start with the event display. That is basically a Knative serving service that is going to receive my events here. So being a Kubernetes-based platform, we have an API group serving Knative dev, and this is a kind of a service. I have given it a name, and it's called the event display. I have created some annotations here for scaling, so it can react to 5 concurrent requests in this particular case. Because it's a little demo here, I want to show the auto-scaling feature. And what we see here, all I need to reference in terms of like, where is my code, like my real application, where is that bundled? It's just a reference to a Linux container that I stored on my private Docker Hub account. All right. I have already installed this one here, as we can see. Let me do kget ksvc. That's the short version for Knative serving service. What we see here is I have the event display already installed, but as you can see here in this video, in this terminal here, it's not yet running because there's currently no load. There's nobody accessing my event display application. Okay, let's make some fun with this one. Now I'm showing you the source. So this is the interesting part, actually. What we see here is we have a different API version group. And what I'm having here is sources.eventing.knative.dev. And this is the kind Kafka source. Inside of the metadata, I have given it a very simple name. It's my Kafka source. And inside of the specification here, I'm giving it Kafka-specific configuration values. I'm using a consumer group here. Right now, I'm using Knative Red Hat Developer Demo for Kafka. I have a Bootstrap server, and that's, by the way, the only really reference that I need to have for my Kafka. As you see here, my work project, the default namespace here that I'm using, there's no Kafka broker running. I don't need that. That's all infrastructure pieces that are shielded away from me. I only have to have the reference here for the particular server. What I'm saying here is I have a topic that's called the my topic. And now all events that are being read from this particular my topic are then routed to a sink. And as the sink, I'm using here a Knative serving service that has the name display events. So now let me apply this one. What we now see here is that I did create a Kafka source with the name Kafka source. It's created. We see here in the video, in the terminal here, container being created. And once the status changes to running, we will see a few eventing display pods coming up. So there's the first one. Now Knative autoscaler was basically, or activator was basically seeing that there was traffic coming in. And then the autoscaler was noticing, well, there's a lot of traffic there. So let me create a few more pods here so I can guarantee that this application called the event display is not going dark. And I'm getting, based on the Knative autoscaling feature, I get a few pods. So if we are interested in how many messages I have in my topic here, I was preparing a little bit. I execute a little script that basically calls into Kafka. And I see I have like 203,000 messages in my particular system running there. Now, as we speak here, the payload is being processed. And then eventually, pods are being cleaned up. So that means once these 200K messages have been distributed to the particular different versions of my deployments here, of my pods, Knative will start to terminate pods as they are no longer needed. So the autoscaler is also reflecting the number of traffic. So when it is relaxing, it is actually also scaling back. So what we see here in our case is once these 200,000 messages have been all processed, we will see some termination, and that just happened right now. And it keeps just one instance running. And if there is, for like default configuration right now, in my case is 2 minutes. So if we continue 2 more minutes without any traffic here, we will also see that this guy is going away. Okay, that's the first demo for running Kafka payload through a Kafka event source to my application. You may now also wonder what this application really looks like. Well, I have a source code file here, and that's really all what we have. It's a Go-based application. There's just a nice display here. The display function is being used inside of the main. So the main basically launches my binary. And what I'm doing here is I get a default client for the Cloud Events API. And with the client, I start a receiver. And this receiver is getting a callback function, which is my display function here. What the receiver does for me, it basically starts a web server. And behind the scenes, the thing is building binding on port 8080. And events are coming on route. So that is the only requirement that we really have here. Okay, let me clean up the resources here for my source. So now it says the source is deleted, and it will terminate the source, and eventually my applications, my event display applications, are being also scaled to 0. So when we come back to this terminal, no more workload is around, and we will see that this last guy is also then gone away. Let's go back to the slides real quick. Oops. All right. So the first simplistic demo that we had was a direct combination of service and a one-by-one, tying it basically one by one to a particular service. As I was discussing before, there's a few drawbacks. I have only one service that can consume, and yeah. So there's another more advanced use case that we have here, and that is that one or more sources can basically emit their events to a channel. The channel is a generic API construct, and as I was saying before, we have multiple ones like Kafka or GC PubSub. Now, we have the nice benefit that we can have actually subscriptions, multiple subscriptions on one channel. On all events that are then on this channel are handled by all the subscriptions that we have here. So in our graphical overview, what we have is basically I have 2 subscriptions to one channel. And that means that both of these services, they will get the same events here. So there is an advantage that I have no longer a one-by-one connection issue here. I have multiple subscribers that can consume the same event. So service 1 that we have here could perhaps store the event in a database, and service 2 could do some data processing and could even reply it. The nice thing here is when we actually reply a value, we could leverage the feature of the subscription with the reply channel. So the HTTP response from my web server that is doing the data processing here will be going to another channel. So on this reply channel, I could then again have a lot of subscription that are basically doing some other kind of processing. So the channel API and the subscription with the reply channel give you a powerful tool to basically already build some data-driven applications. There's still one drawback here that you have to manually install if you want to not use the default channel, that you have to install it, which I did very conveniently using the Red Hat operators that I was showing you before. But still, there is no filtering. Filtering can be done by using the broker and trigger APIs, but that is something that is a little bit out of scope due to time limitations today. And now I'm going to my last demo for today. Okay, I'm back on the terminal. And as you see, I deleted the source. That means the source has no longer any events to emit. Then Knative was so nice for me and did clean up all of the resources. I still have the deployment specification for my application, but I have no running pod. So I'm not wasting any compute resources here. Okay, let's go to my channel. With the channel, I was creating a different application that's less or more the same event display. I just gave it a different name. It's called channel display. So we saw that code already. Let's take a look at the next file that I was actually applying already before. So what we see here is a descriptive file for my Kafka channel. It's in the messaging Knative Dev API group, and it has a name called Kafka channel 1. Here in the spec, I'm giving some Kafka-specific configurations. So if you would, for instance, have a different channel, like an AMQP-based channel, you would most likely do something inside of the spec that really makes sense for AMQP. However, in case of Apache Kafka, the numbers of partitions as well as the replication factor are things that you usually configure with your Apache Kafka topic. So this channel is called Kafka channel 1, and behind the scenes, we do basically have a Kafka topic. Let me verify this by showing you. Oops. What I'm doing here is I'm listing all of the topics that are actually inside of my Apache Kafka installation that is managed by Strimzy. So we see we have a topic that's called my topic, and we see a topic that's called Knative Messaging Kafka. That is a prefix from Knative. So the Knative messaging APIs, they prefix their stuff. And because we have a Kafka channel, it's -Kafka. Then the topic has another delimiter here. It's the default that is representing my namespace. And then I see here Kafka channel 1, and this one is perfectly matching the name of my channel. Okay, so this is already there. Now let's see what else we have. Okay, in order to actually get events from a source emitted to a channel, I ultimately need a source. Let me take a look at my source that I have here. My source is a generic container source that basically allows you to bring your own container. So inside of the container source, you can specify an image. And here I have my image. That's a WebSocket adapter. And I have parameterized it with the argument of a source. And this is basically taking a secure WebSocket connection. So my container source is running this WebSocket source, which basically is connecting to a WebSocket feed from the University of Newcastle, reading all of the sensor data that they have, like all of the IoT sensor data that they have inside of their building, like temperatures, etc., and is turning them into cloud events and is routing them to my channel, which in this case, as you would have guessed, is an Apache Kafka channel called Kafka channel 1. However, this goes outside of the cluster. So what we need to do here is we need to have a little bit of an egress rule here. We have to have a service entry, that's some Istio stuff, where we basically allow the host that we are accessing and the protocol, HTTPS and the default port. As you saw, that was WebSocket Secure, but WebSocket Secure is established out of HTTPS, so we see HTTPS here. And we have another virtual service for Istio that we can actually have my application running inside of the cluster, talking to the University of Newcastle. Okay. Let me apply my source here. And now I see container sources being created. The status here is creating the container. And very soon it will be running, but nothing will happen. So let's wait a second until we get the running status. So now the source is actually already receiving messages from the Newcastle University and is throwing them at the channel. However, I don't have any subscription, so nobody is right now interested in reading the events. Now I'm using the subscription to basically route the events from a channel to a configured service. I use a subscription for this. The subscription has a type name as a name subscription 1, and it says I want to read from the channel, which is again my Kafka channel 1, and the subscriber is a reference here to my service, the channel display. So now let's apply this one. And then we will see a lot of pods coming up for this particular subscription. If the demo gods are with me today, looks like they are. So now again, the same logic that was happening before is all of the messages from this source, they are going to an Apache Kafka channel, and they are actually persisted in Apache Kafka. Now, once I have the subscription, the event delivery kicks in, and all of the messages from the particular channel are then routed to my HTTP endpoint for my channel display. And what we see here is now the system is distributing all of the messages, and I get a lot of pods here. Now let me see if I can apply a second subscription to a different service. So I have a second subscription. So what we see in a few seconds is that we have a few more pods coming up that are then handling events for subscription number 2. So we will see channel display and channel display 2. Those are completely different services, all running against the same channel, but are managed by different subscription. So what we see here is I have a lot of display 1 pods here, all of processing the data here. And for channel display 2, based on or managed by the second subscription, containers are being created. The window is a little bit small here, but you see now I do have a lot of pods running here. All right. What you see here is as well that now after the buffering, the traffic is relaxing. A lot of the instances are being terminated, and only those that are relevant are being kept alive by Knative. This basically concludes the demo. I now have a little bit of a summary. So Knative, and particularly what we saw with the eventing part and also integrating Apache Kafka infrastructure pieces with the Knative Kafka source and with the Knative Kafka channel, is really giving you a good flavor to actually run your Kafka-based workloads and deliver them to serverless product. I would like you to recommend 2 links. Go ahead and play with Knative. There is an upstream tutorial that shows you how to install it, install on different clusters, including OpenShift. And nonetheless, for our Red Hat serverless product, I was already showing you the operators in the preview, in the browser when I was showing you my cluster there. I would also like you to reach out to this website where you can learn more about our tech preview for OpenShift serverless. And that basically concludes the demo. And let me stop screen sharing here.
All right, so we're going to have some questions for you, but we only have a few minutes left, and I've tried to answer a lot of questions in real time. So we got Matthias here on the screen. Okay, and so Matthias, there's actually a couple good questions. Those are kind of deep dive questions I want to make sure we touch on. One is, what about a fan out scenario? So, fan out in the traditional messaging enterprise integration pattern. And then what to do with making sure every message is processed?
Yeah, in terms of Kafka, we were using here the exactly once delivery mechanism. So the messages are basically like from the different topics are being read. In our case, we had a Kafka topic that is based on 100 different petitions, and the source, for instance, is implemented that way that you have a Go routine that is basically a match, like one Go routine is matching one partition and is delivering the messages to the HTTP channel. And then based by the scaling mechanism, they are basically round robin and distributed to the different services. But under the lines here, in terms of Kafka, it's the exactly once delivery mechanism that's applied here.
Yeah, once delivery. So that's a good point. And then there was a couple questions around the channel, and I think the channel is kind of confusing. Is the channel itself also a Kafka topic, or is the channel separate from being a Kafka topic? Can you speak more to that?
Yeah, sure. The channel basically is an HTTP application. So it has incoming messages that are, for instance, emitted by a source to a channel. They are received over HTTP. So our source that we saw in the second example was a WebSocket-based source. They read messages from the third-party system, a WebSocket connection, and then these events are actually being turned into cloud events and being thrown at the HTTP endpoint of my channel. The implementation for the specific Kafka channel then matches every incoming message that's basically entering the channel through HTTP are then being persisted on a Apache Kafka topic. So the messages that you see on the Kafka channel are actually being persisted and made available for as long as you want, and as based on your configuration for Kafka. And you can actually also access them using your standard Kafka tools. So they're based on Kafka topics, and then they are basically rerouted as soon as you have multiple or one subscription, as I was showing in my demo. So the underlying storage mechanism for a channel is basically, in our demo case, was Kafka. But the channel on its own, like the interconnection is basically, it has an HTTP endpoint, which basically receives events. And then once you have a subscription, the messages are actually being read from the particular Kafka topic that's backing this particular channel, and then being forwarded, as if you will, to the particular consumer, which is a service in the subscription there.
Okay, and and we're out of time, and I apologize. There's more questions, but I try to get to as many as possible. But one that is the last one I'll throw at you here, Matthias, is Kafka significantly better than other queuing or messaging solutions that are out there? And what's your opinion on just Kafka versus, let's say, AMQP or some other messaging broker? To kind of put that in context.
I think that's really based on the use case that you have. So I would not recommend to go blindly with Kafka. It's really based on the use case that you have. So Kafka is good for certain things, like it's very good. There's a good disk operating I/O around it, so you can distribute and scale very fast. And also Kafka as a scaling mechanism is very nice. Like if you increase the number of petitions on your topic, you can add multiple more consumers to that one. So you have like horizontal scaling there. In other more traditional messaging systems, that's slightly different. So based on the use case, I would actually recommend going with the messaging system that makes sense for you.
Okay.
And then Kafka is
sorry.
One more plug. And Kafka has also some nice APIs around it, like for data processing. For instance, if you're interested in doing like full stream processing on your Kafka messages, then you could, for instance, use the Kafka Streams API with the, for instance, Quarkus Kafka Streams extension. So then you have like full-fledged APIs that are really making sense in a particular context. So it gives you a good tool for various things, but really, if you have certain use cases, double check if they make sense to use Kafka or not, as a generic recommendation.
Okay, and if you have a GitHub repo where you have some examples or anything like that, feel free to, let us know about that one. And if anybody wants to email me and ask me more questions, you guys have my email address based on the session. But we are totally out of time today. And thank you so much, Matthias. Thank you all for showing up. We had a
Thanks
huge
for having me.
Yeah, awesome stuff. Well, thank you guys. We'll see you at the next DevNation Tech Talk.